She should be better. She's, by then, she won't even be a puppy anymore. Okay. Okay, you guys. I did with my marker on my computer. It's hard on the computer with the mouse. Okay. Linearization. Okay, you guys? And actually, your data might look something like that. Rare is going to be smooth. Chapter 8, we're going to look at approximating polynomials with lines, and we're going to go further. We're going to get up to quadratics, quartics. We're going to do a whole bunch of stuff. That's what Chapter 8 is all about. So this is just kind of getting you set to do this. And we are going to do a linear approximation. Because what happens, remember from our derivative lab, if we zoom in on this dot, what happens to the function? It starts to look like a what? Okay, you guys, I need you to focus here because there's going to be some hard stuff here. So write the slope of the tangent line as a function of x. So what's the slope of the tangent line? I want slope of the tangent line right here. It's what? It's going to be f prime of a. That's the slope of my tangent line. Okay? That's this, which is, I want as a function of x, I want it as dy over dx. Is that okay? That's what slope is, right? I had to remember what I was going on about this. So, guys, this is dy, and this segment is dx. Okay? It's the change in y over the change in x. I want to write the equation of the line using this point, a f of a. So remember, it's y minus y1 equals m x minus x1. There's reasons for why I want to do this dy over dx. Okay? So what is this going to be? It's y minus, what's y1 in terms of a? F of a equals my slope, which is f prime of a times x minus a. Is that okay? Jordan? Is that okay? And you have to tell me, because you know my voice is bad. It's going to be bad until probably after Thanksgiving, because I'm not supposed to be talking. It feels bad. Okay. That's the equation of the tangent line. James? Can you solve that for y? So what's y equal to? It's equal to f of a plus the derivative at a times x minus a. That's going to become very familiar to you. Part of a bigger picture. This is just the line. That's what they call the linearization. We don't have to learn anything new, do we? It's just the equation of the tangent line. So when they ask for the linearization, all they're asking for is the equation of the tangent line. You want to solve for y. That's the difference here. So we can approximate our function on the tangent line. It's how your calculator works. It doesn't do e squared or whatever, 2.7 whatever. It uses the tangent line because the calculator can do things more quickly on a line. Well, except that their increments, their dx's here, are so small you can't see them. But if I go over a certain distance here and up here, I can estimate the real value right there with this. Well, that's what we're going to do tomorrow. All this that we're going to do today is just do the linearization piece, write the equation of the tangent line. It's a pretty good approximation for the function. If I had more terms, it would be a better approximation. And we'll be doing that. Actually, we'll be doing that right after winter break. Okay, so we're going to do chapter 8. We're going to get through the first 4 sections before winter break. Actually, we're going to get all the way through chapter 8, I believe. And then we're going to come in and hit AP problems after winter break on this. Okay, I don't think there's anything else there. Okay, let's try a problem. That's on your sheet, right? Okay, and we're just going to write the equation of the tangent line. Except I'd like to have the question. What? It's just probably a typo or something. What does that look like? What does e to the minus 2x look like? You need to know this. I'm going to get a book, though. I want to see what the question is. And it might be out of the old book. I don't remember. It's reflected. It's e to the x reflected off of the y-axis. I don't care about how steep it is. That's not that important. It's just fighting the linearization. I'm pretty sure that's all it is. Okay, so it's going to look like this. Uh-oh. I'll get it fixed. Okay. All I want to do is write the equation of the tangent line. Oh, Natalie? At right here, at a equals 0. What's the slope going to be, positive or negative? It helps me to see the picture. Okay, so let's write that. I just do the problem. Y minus y1 equals m x minus x. What is f of 0? 1. So it's y minus 1 equals my slope, and it's x minus 0. So what's the slope? David, what's the slope? It's the derivative with respect to x of e to the minus 2x, evaluated at x equals 0. You have to have a number here. So it's going to be what? Negative 2 e to the negative 2x at x equals 0. Substituting that in, what's the slope going to be? Negative 2. So y minus 1 is equal to negative 2 x minus 0. I kind of like to keep the x minus 0 there. There's a reason in the future. You may not remember it. So it's 1 minus 2 x, if that's what you want for your linearization. And if I were to put that on my graphing calculator, it's exactly what I would get if I drew the tangent line there. I like to see it this way, minus 2 x minus 0. Because this is what's telling me what I'm doing. Right, this isn't really any different or any harder. Now, the next question is harder. Yeah, that's easy. So we get to this.
Oh, let's not do that.
Okay, first off, they tell you what the equation of the tangent line is. So let's go ahead and prove that that's what it is. Show that that's the approximation. Now that's what they would do on the exam. They would say show that because I'm going to use that later on.
They ask you what window you use.
No, I'm going to ask you what window to use because that's the hard part. Okay, I want to show that that's the tangent line. Somebody want to come up and do this? I'll give you some time to do it. Kevin? James, are you going to come up and do this? Either on your paper or... Okay, give it a try. And we're going to do this at a equals 0. Yeah, what is that? Okay, this is y prime at x equals 0. So it's negative 4 times 2, negative 8. Oh, well, that turned out to be nice, right? Negative 8. Because of the quotient rule. It's the denominator times the derivative of the numerator, which is 0, minus the numerator, which is 1, times the derivative of the denominator. Okay, shh, you guys. Yes? No, it's low d high. Low d high minus high d low over the square of low we go. Okay.
I did it to the negative 4 at the top.
Yeah. Doesn't matter, they're both good. The alternate solution is to say y equals 1 plus 2x to the negative 4. You're right, that's easier. Because I'm just using the power rule and the chain rule. Yeah. See you guys. Well, it's negative 4 times whatever this is. If you go down 1, negative 5, but you get it right if you go the wrong direction, times the derivative of the inside, which you have to do anyway. Okay, that way, please. Now, you're going to need your calculator for the next part.
How should you get from the like?
You're going to evaluate it at x equals 0.
You add 0 in, and
It's not a decimal point. Okay. Oh, I'm missing the other half. Now, we want to get this. Your handout looks a little different than mine, because yours is right. We want to get this to be within, we turn it over, example 3. I want to take this same function and rewrite the inequality with, I want to get it within a certain error. So let's first, I'm going to add a page. Yeah, I don't know why. Oh, is it there? Is it on the bottom? Oh, there it is. Okay, I'm going to graph this function first. Now, should we try this with Inspire? The reason why I choose this, but I get color. It still is done the same way. So I'm just going to add a page. Okay, add a graph. And the function was 1 divided by, no, they added it. 1 plus 2x. Hey, you guys, get your calculators out because this is the hard part. You can use a regular calculator. Just type it in and graph it. It's y1. Enter. Okay, Matt, what do you have on your calculator?
it doesn't have anything on it.
I see that. I have calculators. You can use it. You can borrow an Inspire. I have my color Inspire here.
It's cool.
Oh yeah, it's nice to have the color. Because I'm going to draw in. Well, you know what? I don't only want to focus at 0. You guys, I don't want all this left stuff. So why don't we go from -1 to 2 on our window? Now my window is going to be different than how you do it. It's going to be different than mine. I'm going to do here. It's pretty close though, window settings. And so I'm going to do -2 to 2. And then you have to tab it down here to get OK. You don't have to do that on there. That's better. You have to add a graph.
Yeah, I got
It's, yeah.
Oh, I got that. I just don't have a mouse.
It's a touchpad. Okay, what's my it's 1 minus. Now I'm going to add in another function. I pressed tab to get down here, and it was 1 minus 8x, right? Minus 8x. There it is. I'm going to zoom in. Zoom 4. I'm going to zoom in 3. So I'm going to zoom in right here. And I want my error, the difference between the line and the curve, to be within a certain amount, which would be 0.1. I'll zoom in one more time. Oh, that looks nice. Okay, so I'm taking a picture of this. It's Control a T, I believe.
How do you get 2 graphs?
Go to a new page and start over. Okay. Okay. There it is. I want this distance here. This is the error. I want this distance right here and right here. I want to find the x values such that the difference between the line and the function is going to be less than 0.1. As an absolute value, it would look like this. It would be L of x minus my function, f of x, to be less than, or we could do equal to 0.1. I haven't done it yet. You haven't done it yet. That's my function. It's the same one. So here's the function. You don't want 2 graphs on 1 page. Oh, just tab down on the Press tab and you'll get down to the viewing window.
Yeah. It's on
It's, tab is right here. See, tab gets me down here. Tab moves me around my screen. That's what it does.
I got you. I got you.
And then I can hide it. Pressing that, they call it chevron. Okay, back to the smartboard. Okay, you gotta understand the math. What?
So, did I do it right on mine?
Yeah.
Awesome.
Where's your curve?
That's what I'm trying to grab. I got my hand on it first.
Oh, yeah, you're right. Then you have to do, we have to type it in 1 plus whatever it is. You're right, you're fine. Whatever the 1
Yeah, but I can't.
divided by, it tells you parentheses, 1 plus 2x.
That's not right.
Close your parentheses to the 4th. There's your arrow. Where's the caret? To the 4th.
Oh.
There it is. Now you're going to have to zoom in on it. I don't really care about the other thing. I just want this. Okay, if I solve this absolute value inequality, you guys ready? Jordan, do you know how to do this? I want the distance. How do you find distance? It's absolute value. I want the distance. This distance is too big. Okay, girls? I want the distance, the difference between the line and the function, to be within a certain error, 0.1. If I'm a machinist, I'm going to have to worry about these things. They throw away a lot of parts when they don't machine it close enough, because you get errors. By the way, just to make you feel bad, this is one of the 8th grade algebra standards. About getting the errors, yes, I don't agree it should be there, but it is. An 8th grade algebra standard is to be able to do this.
Yes.
Yes, they want the error. Because if I'm a little bit off on the x's, how far off am I on the y's? That's all it's asking for. So to solve this just means the distance between the line and the function. Order doesn't matter. I might have written it the other way around. I don't know. And so then L of x minus f of x, the difference has to be trapped between 0.1 and negative 0.1. Do you agree? Okay. And if I solve for L of x, it's going to be between f of x plus 0.1 and f of x minus 0.1. And this, you have to do this in your homework. So I'll tell you how to do this. So you're going to put these into your functions. I'm going to have to do something a little bit different. Oh, I don't know how to turn it off on this one, though. So I'm going to graph these lines. I still want to zoom in even more, actually. And you're going to graph these lines. And it's hard to get the right window. That's why I say include your window. Okay? And you're going to read off your intersection points. I'm going to try. I'm not experienced with the Inspire, so find out what happens. I want to zoom in again. Oh, I'm out of that, so I got to zoom in. Zoom, zoom. Whoa. I don't know if I want to zoom in that much. Yeah. I go to menu, window type. I want to zoom back out. I don't like that. I do have games. Okay, so we have to graph. What are we going to graph now? You're going to do y1 minus 0.1 and y1 plus 0.1. So I'm going to try and do this. Now mine is f1 of x, so I'm okay. I can still do it as a y, like a y1. It won't be called y1. So over here, now to get to this piece down here, I got to tab it. And so I want to graph y1 of x, or f1 of x actually. So I do f1, and you have to put of x in there, or it doesn't like you. Plus 0.1. Oh, it didn't intersect at all, did it?
Wait, so what?
I didn't.
First equation.
Let me move this guy out of the way.
So on this one, I would do y.
This is the blue one. I'm using that inequality I saw. There's a couple ways you can do it. This is a way to do it. This does not intersect my tangent line, does it? Tangent line was the green one. Doesn't intersect it. So now I'm going to do y1 minus 0.1. But you're going to, and we can go back to I can go back to the 84 and do it on that as well. So I'm going to tab. I was just curious. So it's f of x1, or f of x, f1 of x. Minus 0.1. This will be a different color, I hope. And look at that. It looks like it does intersect. Right up here. I'm going to move this one. I like the fact, oh, whoops, that was not what I wanted to do. Well, you know what we're going to do? Twice. Am I back to the original? No. There. Okay, we'll do this again. You're right. Okay, now I wanted to get these labels out of here. Okay, there's that label. Oh, look at that. I can slide this too. Oh, look at that. I got an intersection point there. Can I move this label? Yes. Okay, I need this intersection point. And you guys know how to intersect curves on an 84. But what's nice on this one, and I may have to go to my computer, intersection is analyze graph. Intersection is 4. Oh, it's hard. It is hard to do it. And I want this. Oh. Yeah, it's going to make me do it on my computer. I don't know why it doesn't work on the smart board, but it doesn't. So I'm just going to. Okay, that. And there. Intersection. There it is. There's your intersection point. The X's. I only care about the X's. And guess what? I got to do it on the other one, too. So let me take a picture. So that's kind of cool because I get the color. Whoa. And you can sort of see my window. I'm at 1.26 on the Y's. I can press window if you'd like to see that through 0.51, and on the X's I can't see it. So let me go back here. Can I make this bigger? I can also look at it. Oh, that's not what I wanted. Okay, let's finish this. Now, I want to get the upper one, so I'm just going to grab this because I can. Because I just grabbed the wrong thing. Okay, do you see the other intersection point? Right there. Look at the Y's, 1.53. If I want to go into my window and you want to look what my window was, it's easier, I think it's easier on the Inspire. So the X's are going from negative 0.13 into 0.139 on your window. You might want to write that down. How about if I take a picture of it? Oh, come on. What? Yeah, these are the X studies. They're all positive, aren't they?
But it doesn't intersect with X plus 1.
Yeah, no, it doesn't do the plus 1.
So that
Sometimes it will intersect one of the lines and the other. You just don't know. You have to do it to know. Now, Mrs. Hersman says to turn off your original function because it's in the way. Oops. Okay, let's find this intersection point. And I'm going to do it on the computer though because I can't. I should figure out how to do it on the smart board. Analyze graph, intersection. And this is the nice thing about this. You have to click the two graphs. And there it is. There's the other answer. You can certainly borrow my Inspire calculators. They aren't in color. The ones in color is the one David has. No, I'm not sure this is the right answer because I moved this graph around, but it's good. You got the idea. I hope. But I thought it was a good question. Okay, no, I don't want that. I want this.
Oh, okay.
Oh, yeah, I can see like laws.
There it is. Okay, that's what you have to do on those problems that ask you to do this. You want me to go through it on the 84? You got it? Do you have this on the 84? Yes or no? Oh, do you have it? Do you understand how to do this?
Wait, so
I got calculators.
what does that help us?
Because the x is, when the x is between negative 0.4045 and, what's the upper one? 0.055, then the difference between my line and my curve was the red one, right?
Yeah.
And the green. This difference here between these two will be less than 0.1. You could graph the absolute value inequality if you'd prefer. That also works. This is just a method. There's more than one method to doing this. Yeah, I got 2 extra calculators sitting here. Plus, I have a whole bunch of Inspires. As long as I'm within this x distance, whatever that is, the difference in the y values between L and my actual function will be less than 0.1. That's how you write that. That's how you say it.
On this one, so I just turned off the other 2 graphs.
Right. You might have to turn off some other 2 graphs, the other graphs, yeah. It only intersects the one curve. I know what other problems in the homework, it'll intersect one of the lines at one point and the other line at the other point, other curve. So you don't know till you do it. And that's what the homework is like. And that's all we're doing on 3-9. Yes. I got to grade one though first. Okay.